Hello all, welcome to Indian Techies. Today we are going to discuss about binary searching. In our previous session, we have discussed about linear search or sequential search. But when you see linear search exactly, the number of comparisons are becoming more in the worst case. So, what do you mean by worst case or what do you mean by best case? Suppose you are searching a value in a group of values, that is in an array. So if your searching value is at first position, that is your best case, because you will get your element by comparing with one element. You will get your value by comparing with only first element. Then no need to compare with remaining elements. What do you mean by worst case means? Suppose the list consists of many values. If the value that you are searching for is available in the last position, then that is worst case, because you have to compare all the elements from the first onwards. As a linear search or sequential search performs searching process from the first element onwards. Even though if it is in the last, you should start your search from the first position onwards. So for small list of values, linear search works fine. But if the size of the list is very big, then comparing that many number of times takes the time complexity, right? So it will take more time for comparisons. For that purpose, to overcome that problem in linear search or a sequential search, we are going for another concept called as a binary search. Actually, binary search applies divide and conquer method. So, divide and rule. This method will be applied on the binary search. The word binary means generally 2. Unary means 1, binary means 2. So, why we are calling this one as a binary? Because the total list of elements will be divided into two parts, two equal parts. That's why we are going to call this one as a binary search. Before performing the binary search, the first condition is all the values in the array should be in ascending order or descending order. It should be in any of this order. This rule does not apply for linear search, because in linear search all the values that are available in the array or list of values are in random. There is no particular order. That's why linear search worked out. But if you want to perform the concept that I am going to do right now, the first condition that you have to keep in your mind is all the values should be in ascending order or descending order. If the values are in random order, then you have to make those values to be in ascending or descending order. Then you will be having a doubt, like in linear search we are just doing comparison and whether element is found or not. Then in binary search, so you making the elements to be ascending order means that is also one type of comparisons and converting the list into ascending or descending order. Always converting these random values into ascending or descending order also occupies some time complexity. Yes, but we don't do this every time. Whenever the list has been created for the first time, all the values, if you make it as a ascending order, from next time onwards you will directly perform search, right? Now let us see a binary search method with an example, right? So let us see the example. Now I am taking some list of values 2, 3, 4, 5, 6, 7, 8, 9, 10. Suppose this is an array of size 10. Let me put the index values as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. As we all know that array always starts from 0th position and ends with last minus 1. So the total is 10. Right? Now I am entering some values. Okay, let me consider the name of an array as A, whatever the name that you keep, just for easy purpose. Now I am entering some values. So I am entering or I am storing the values in ascending order only. Since we have not discussed the sorting algorithms, directly I am arranging the values and entering. Suppose I am entering like 5, 7, 11, 13, 19, 23, 35, 46, 57, 78. Now, these all the values are in ascending order. First, what we have to do is, we have to identify some positions. Listen clearly and carefully. Always consider this first position as low. Remember, I am telling the word called as position, means I am assigning low as 0. Don't consider the value, right? I am considering its index position. So I am considering 0 as low. And always consider the last position, that is 9, as high, right? So always consider 0 first position as the low one, and the last position, okay, will be considered as high. Now, as I told you that it is a binary search. So what do you mean by binary search? You have to divide the total list into 2 equal parts. On what basis? See here. So you have low value and you have high value. Identifying low and high is easy. First position always 0 at the starting of binary search. 0 low will be 0. The last position will be high. Now calculate mid value. That is, mid is equal to, you are having a formula like low plus high by 2. So what is the low value here? 0. What is the high value here? 9 by 2. Generally we will get 4.5. It is a regular mathematical calculation. But here, since we consider it as an integer, we will be considering only 4. Mid will be declared as an integer value. This will be considered as 4. Now, the mid position is 4. Right? So, we got the low value, we got the high value, and we got the mid value. Suppose I want to search one value, whether that value is available in my list or not. I want to search. So, for example, I want to search whether 46 is available in the list or not. Right? Now, if 46 is available in the list or not, always remember, we should compare our element that we want to search only with the mid value. We don't compare with any other values. We just compare only with the mid values. So, condition number 1. Whether my key, my first condition is whether my key is equal to A of mid. So, what is my key here? 46. What is mid value? 4. That is A of 4. So, 46 is equal to 19. No, this condition is false. Once this condition is false, the next condition you have to check is whether this key is less than A of mid. Because we already got confirmation that it is not equal to mid. If it is equal to that mid position, then obviously the value is found. You will stop your searching. If it is not found, if it is not matched, then the next condition is check whether your key is less than this A of mid. That is, what is your key? 46. What is your mid value? 19. 46 is less than 19? No. So, once the meaning is 46 is not less than 19, since all the values are in ascending order, what is the meaning? Your value is not available in the left part of the mid. This is mid part. Its left side 46 is not available since the values are in ascending order. If it is in random order, that is different. But since all the values are in ascending order, the value is not less than 19. So, you no need to check left part of this mid. The meaning is half of the elements has been skipped for comparison. Suppose if you have 1 lakh elements, if your value is not mid and left side of the mid, so half of the elements, around 50,000 elements, you no need to compare. Then I will check. What do you mean by the next condition? Whether my key is greater than A of mid or not. It is not equal to mid position. It is not less than mid position. So definitely 46 greater than 19. Previously it is not mid, not left side. So 46 greater than 19? Yes. Now we got a conclusion that the 46 value is greater than 19. So what do you mean by greater than 19? It may be towards the right side of the mid position. We are not telling that exactly it is available. It may be available towards the right side of the mid value. Means in this right side value it may be. Right? Now we have to perform searching in this part. Again what you have to do? Again apply this total procedure in this right part. Now forget about this total. Forget about mid and left. In this right side part, again what you have to do? Again you have to find low. Again you have to find high. And again find the mid value and compare. Now in this right side part, from 5th position to 9th position, find the low and high. Identify. So already 9 means it is high. So we need what? If you want to get mid, you need both low and high. So make this 5th position the previous mid position plus 1. The next position of the previous mid becomes the low. Means mid plus 1 becomes low. Now you got low value as 5, high value as 9. Again perform this process. What is low value now? 5. What is high value now? 9. So 9 plus 5 by 2. It is 14 by 2. It will be 7. So what is your mid value now? This is your mid value. Right? Now start comparison. What is your first condition? Whether your key is equal to A of mid. What is your mid? 7. A of 7, 46. What is this here? 46 and here also 46. So your element has been found. This is how you perform binary search until your element. You may have question, what we have to do if the value is towards the left side instead of right side? Nothing. Before mid value will be considered as high. Mid position. Before mid minus 1 becomes high if your value is left side. If your value is right side, mid plus 1 becomes low. Now, what is the condition if your element is not found? Because always we will be comparing with mid. If the element is found, okay. If the element is not found, you will go towards the right side or you will go towards the left side. Again find low, high. Again divide, find the mid. Again this procedure continues. But when we will stop this procedure, remember this point clearly. Whenever we divide, what we are going to do? We are making, in the right side means we are making low as mid plus 1 or high as mid minus 1. Either these two things, any one thing will be happening until element is found. Suppose when you should conclude that my element is not found. At particular situation, low value crosses high. So always low value should be less than or equal to high only. Then only your searching continues. Whenever this condition is false, the meaning is your element that you are searching for in the list is not available, is the meaning. Means low should be less than or equal to high. Low and high, everything can be same. There will be situations like where low, mid, high may be same. But always low should be less than or equal to high. Low should not cross the high value. At particular situation, you will make this one as high, this one as high, or low may go to the next. At this position, low should not cross high. So high will come this side and low will go that side. That situation means your element is not in the list. This is how we will perform the binary search algorithm. Here we will be having number of comparisons, but when the list of size, size of the list is very big, then binary search would be better when compared to the linear search, because we will be skipping many number of comparisons. That is the major advantage of binary search. This also follows divide and conquer method. Now we will see a program to perform binary search in a simple way. Let us see the program. Now, as usual, hash include stdio.h. Now next, void main. Now I am going to declare the variables. I am declaring a array size of 100, because out of 100 how many you want you can decide by yourself. Next, out of 100 how many you want, for that n. Next one is we are going to take for loop I value. Next, always we will take low value, mid as well as high. Also we are going to take an element key. Key, what is the key? The value that you want to search for, that is considered as a key. Next, out of 100 how many values that you want? That is printf enter list size. You can write any text of your wish, that is enter list size. Next, scanf %d %n. Now I have taken the input. Out of 100 you will give 10, 20, 30 or whatever it may. You have to take that many values as a input. Now printf enter %d values. We have to enter in ascending order. We are not writing logic to make the values in ascending order. So %d values in ascending order, that is n. Right? Now what we have to do? We have to enter the values in ascending order. Right? For I is equal to 0, I less than n, I plus plus. Scanf %d %a of I. Close. This for loop takes input for n number of values, whatever the size that we give. Next, we also should take the input for the value that you want to search from the above list. That is printf enter key to search. So whatever the key that you want to search, I am going to give input, that is scanf, since it is an integer, %d %key. Now my input has been completed. Right? Before performing binary search, what we have to do? We have to set the low value and high value. Now initially always the low value will be set as 0. High value will be like n minus 1. That is, if 10 values are there, then 9 will be the last position, that is 10 minus 1. So n minus 1. Now I am starting a searching, that is while low less than or equal to high. As I already told that my comparison continues until low value is less than or equal to high only. Right? Now we already have low and high. So calculate the mid value. Mid is equal to low plus high by 2. Right? Now start your comparison. That is, if your key is equal to a of mid, then here we will not understand whether the list, the loop has stopped after finding the element or after ending to the list comparisons, or after all comparisons has been completed. We will not have any clarity whether the loop has been terminated by finding the value or by not finding the value. For that purpose only, I am taking here one more variable called as flag. Initially I will assign it to 0. Right? Now whenever my element is found, I will set my flag value to 1, since I no need to do comparisons more, because I have found my element. So I am using break statement. Close if. If element is found. Suppose if element is not found, that is else if key value is less than a of mid. Because if it is not equal to a of mid, it will be maybe less than a of mid. So less than a of mid means what is the meaning? So left side what will be there? Low will be there, but high will not be there. So create high value, that is high is equal to mid minus 1. Suppose even this condition is also false, then obviously what is the meaning? The value will be, if it is there, it will be towards the right side. So you no need to check the condition, directly write else. In right side, what will be there? High value will be there, low will not be there. So low is equal to mid plus 1. Close else and close loop. Close else and close loop. This is the basic logic for binary search algorithm. So how this continues? You will be having new low value and high value. It will check this condition. It will calculate mid value and it will identify. If it is found, this loop stops. If it is not found, high value will set or low value will set. Means new high or new low. Again loop goes starting, and with this new low high values, again new mid value will be calculated. Again comparison runs. Element is found, stops. Element is not found, new high value or new low value will be set. Again goes to the starting of the loop, again calculates with new mid. This process continues until element is found or until low less than or equal to high. Condition false, becomes false. Is it clear? Right? Now, once this total logic is completed, if element is found, you have to print element, otherwise not found. That logic we will be writing now. So, the logic for element found or not. Now, when this flag value will be set to 1, if element is found only. Initially, what is the flag value we have set as 0. So, whenever this flag value is set to 1 means element is found only now. So, we will check this. That is, if flag value is double equal to 1, that is equal to 1, then printf element found at percentile d position. What is that percentile d position? Mid only. So mid plus 1. Why we are writing plus 1? If mid value is 5. Since array starts with 0, for our visibility it is at 6th position. That's why I am writing mid value plus 1. This is if element is found, that is if flag value is equal to 1. So if flag value is not equal to 1, that is if this condition is false, then printf element not found. Right? Close else and close program. This is how we will be performing binary search algorithm. To overcome the disadvantages in linear search or sequential search, we will be approaching the binary search. Binary search is best suitable for the list of elements with huge size. Linear search is suitable for with list of elements with less size. Hope you have understood the concept of binary search algorithm. Thank you for watching. Please like, comment, share our Indian Techies video.